A very good afternoon, students. Today we will be learning all about ionic radii. In my previous lecture, I have told you about covalent radii, metallic radii and van der Waals radii. And in this lecture, we will be talking about radii of the ions when they are present in a ionic crystal. So the topics I will be covering here are what is ionic radii, then factors affecting the ionic radii, periodic variation of ionic radii, and then I will tell you about the methods to determine the ionic radii values and some related problem. From the name itself, you can understand that ionic radii corresponds to the radii of ions in a ionic crystal. And in a ionic crystal, we can measure the internuclear distance between the nucleus of the anion and the cation by using F-ray diffraction. And we can get the internuclear distance that way. But if we divide the internuclear distance or in ionic bond length by 2, it will not give us the radius of the anion or the radius of the cation, because the radius of anion will be much bigger than the radius of the cation. So there are some indirect methods to determine these ionic radii values that I will discuss with you later. But you should know that these ionic radii they are actually dependent on the environment they are present. That means they will be affected by the other ions or other interactions present in the crystal lattice. So first let me tell you, let me give you an idea about the radius of cation and an anion. So what happens when a cation is formed from a neutral atom? The radius is less than the neutral atom, and when an anion is formed, the radius of the anion is much bigger than the neutral atom. So why this is happening? Because you see here I have taken the example of sodium and sodium plus and chlorine and chloride minus. So in sodium we know the atomic number of sodium is 11. So number of proton in the nucleus is 11, and in the neutral atom the number of electron is also 11. But when we remove one electron from this neutral atom, Na plus will be formed, and in that number of proton will be unchanged, so it will be 11 in number, but number of electron will be less than what there were in the neutral atom, so it will be 10 in number. So the same nuclear charge will attract less number of electrons, so obviously the attraction force will be more and the size will be less. And in case of this chlorine to chloride minus, what happens, you see, chlorine is having atomic number 17, and so the number of proton in the nucleus is 17 and number of electron also is 17 in number. And when this Cl minus is formed, so one electron is more in case of Cl minus. The nuclear charge remains the same. So here also proton number was 17 and here also the proton number was 17. So as the number of electron becomes more, so the nuclear charge felt by the electrons will be less because of more number of electrons, and so the ionic size is more than the neutral atom. So in case of cation the size decreases, and in case of formation of anion the size increases. I hope this is clear to you now. So here I have taken few examples as well. You see here when cation is formed, M2M plus electron, the atomic radius of lithium is 1.52 angstrom, whereas the ionic radius of Li plus is 0.60 angstrom. So this is much less than the neutral lithium. And in case of sodium, it is in neutral condition, it is 1.86 angstrom, but when it is a cation, that is Na plus, the radius is, ionic radius is only 0.95 angstrom. In case of formation of anions, I have taken the example of Cl and Cl minus. So here you see the atomic radius of chlorine is 0.99 angstrom, whereas that of chloride is 1.04 angstrom. So this is more than what we had in case of the neutral chlorine. And if we take the example of sulfur and sulfide, you can see in sulfur the atomic radius is 1.00 angstrom, whereas in case of S2 minus the radius, ionic radius value is 1.84 angstrom. So this is much greater than what we had in case of neutral sulfur. So we can say that from these values that when a cation is formed, the radius decreases, and when an anion is formed, the radius increases. You will be able to answer the questions related to these topics. And today I am finishing my lecture here, and thanks for watching my lecture, and I will see you in my next class.